since interest is compounded once a month, and this is made per week, then by the end of the month, we'll just assume about 4 weeks. I know that's not completely accurate. Sometimes we have 5. We'll just assume 4 weeks to keep this calculation simple. So 4 weeks, and that tells us a total of, this is 4 weeks per month. So we have basically negative $40, or yeah, negative $40 per month would be the outflow. That being said, this makes perfectly fine sense, because if you look at the month interval, like between 0 and 1, for example, and you make 1, 2, 3, 4 payments spaced out equally, well then by the end of the month, it's equivalent to making one $40 deposit, because now you officially have your 40 bucks in at the end of that month. Following along with our theme that payments are made at the end of a month. Just because you put it in there doesn't mean it needs to do anything. It's sort of like loading up a BB gun, for example. You can put a bunch of BBs in there, but it doesn't mean they're coming out at the same time. Maybe if you have a semi-automatic, you can fire them all out at the same time. Maybe a bad example, but the idea is that as long as it's there at the end of the month, you're in good shape. So we're also told that we have 4.2%. So our I percent in this problem is 12, and not 12, 4.2, excuse me. Our compounding period is monthly, so we have 4.2%. That's been the average over the last 4 years. We're assuming we don't withdraw from the account, and we're going to see what we have accumulated in 30 years. Okay, well, we're not going to use the formula. You can use the formula to calculate this, but remember, our calculator uses this big fancy looking thing, and it knows once again to use that formula based on our inputs here. So I'm doing this compounding monthly for 30 years, so that means in 30 years there'll be 360 compounding periods total. I percent is 4.2. My present value is nothing because there's no implication that something would be put in at the beginning like a lump sum, but there's a $40 monthly outflow on our part, compounded monthly down here, so now I can compute the future value. And this tells me that my future value would be $28,773.42. That's assuming that constant rate of growth. So not too bad for 50 bucks a month. Of course, you might think that's not really enough to retire on, and you're absolutely right. 30 years is not a long time to have a retirement account for, and $50 is certainly not enough, even at a gigantic rate of 12%, which is very rare to see. So let's do another problem. Now we're going to use the idea of a time diagram to help us a little bit. This one's a little bit more challenging. So it's not uncommon for people to miss their retirement goals due to poor planning. A person hopes to have $995,000 in his account at retirement so that he can continue to live off of interest. Well, you never really know how long you'll need your money for, so you don't want to assume that $995 will take you all the way through to the point you die, so you want to make sure you're living off of something that's sustainable. For 18 years, he had been depositing $60 bi-monthly. That means twice a month. He was fortunate to have had an average rate of 8.9% APR compounded monthly. Over his final 12 years before retirement, he is able to afford up to $120 bi-monthly due to his growing salary. If he does that at a higher rate of 9.5% compounded monthly, how much will he have to deposit today to meet his goal in 12 years? So, we're going to build our time diagram, and I'm going to label this from 0 all the way up to 30 years. And we know that at 18 years is where we currently are. So this person is currently in this standstill at 18 years saying, I wonder if I'm doing an okay job planning for my retirement. We know that he does a few things. Number one, he's been depositing $60 bi-monthly. So $60 bi-monthly, and what I'm going to do to indicate a payment that's made regularly over a monthly period is I'm going to put it in this little box here, like this, across the entire interval. So PMT equals negative 60 times 2, because this is a bi-monthly payment. It's twice a month. So in a month's span, he's made $120 payment. We now need to find out